Hello, AP statisticians. Here's Mr. Creedon talking to you about conditional probability and this idea of independence. So again, if you haven't checked out our previous videos over this example, we've got a student who is interested in weather conditions and how that affects the bus that they sometimes take. Is that going to make their bus delayed? Is it going to make it on time? And so here in our two-way table, we've got data from a year's worth of tracking that bus and the weather. We can see all 365 days have been recorded and the conditions being sunny, cloudy, rainy, or snowy, and then being on-timed or delayed. And the questions for this video is, what is the probability of being delayed if it is snowing? And a key word here is that if, getting us to the idea of conditional probability. And the second question being, are the events snowing and delayed independent of one another? So let's take a look at what those two concepts mean. For our first question, okay, what's the probability of a delay given snow? So what I have here is I've organized a Venn diagram showing this information so we can break it down. And I'm going to first just make note of what each of these things mean. So we have 8 days where it snowed, but not delay, okay? So it did snow outside, but the bus ran on time. There was no delay. We had 12 times where there was snow and delay. We had 23 times where there was delay, but no snow. And then we had 322 times where neither delay nor snow. We had neither of those two things happen. So let's take a look at this. What's the probability of a delay given that there's snow? So this idea of given, we would write this as the probability of a delay given snow. Or oftentimes we'll shorthand this. Actually, a fair number of times we're going to shorthand this to the probability of a delay given snow. So that vertical bar tells us we're looking at a given or a conditional probability. So what I can see here is we know that we're only focusing on snowy days. Okay, we're only focusing on the 20 days where it was snowy. And then from those 20 days, how many times did we have a delay? So again, from these 20 days, looking at our pink circle, how many days did we have a delay? And that's going to be these 12. So we have a 12 out of 20. So the probability of delay given snow is 12 out of 20, or 0.6. So let's try to figure out, what can we gather from this? What did the 20 represent? What did the 12 represent? So in general, we can say that the probability of A given B is going to be equal to, all right, our first piece is that intersection between A and B. So that's the probability of A and B, also known as the probability of A intersect B, divided by, well, where did that 20 come from? That was the probability of B, or the number of times that B came up. So the probability of B. So that is, in short, our idea of conditional probability. Now, what we can also do is we can reverse the conditioning. So for example, using that, what's the probability of snow given a delay? Okay, so now all of a sudden we don't know that it's snowing. We know that there's a delay, and we're curious about what's the probability that it happened to snow that day. Well, in that case, I've got the probability of A and B. So if I take a look here, the probability that it was snowing and delayed was 12. Oops, sorry. 12 out of 365. That's the probability of snowing and delay, divided by the probability of just a delay. Hey, that's the probability of B. That is 35 out of 365. These are going to cancel. And I get 12 out of 35. So there we see that conditional probability. We reverse the conditioning. The probability of a delay, given that there's snow, is 12 out of 20, or 0.65. The probability of snow, given that there's a delay, is 12 out of 35. This conditioning is all of a sudden changing what we're considering the whole. So now let's take a look at a slightly different question. Is snow and delay independent? So what exactly does that mean? I'm going to first just copy this chart, because that's going to be really helpful for us. So the first question that we are going to ask ourselves is, what's the probability of delay? Like, what's the probability that we hit a delay on any given day? And what we can see there is that's 35 out of 365, or about, I'm just going to check my calculator for this. We'll say that's about 9.6%. 9.6% of the time, your bus is going to be delayed. It's an unfortunate fact of using public transit. But now let's take a look at the probability of a delay given that it's snowing. So you look outside one day and you see that it's snowing. What are the chances that your bus is going to be delayed? And in that case, we see that that happened 12 out of 20, or 0.6, 60% of the time. And all of a sudden, we start to see this relationship. Okay, we've seen that the probability of that delay has changed from, in general, you had a 9.6% chance of it being delayed. But now that you know that it's snowing, you had a 60% chance of it being delayed. And that creates a bit of a problem. The other way that we can see this, so that's one way to show that these two pieces might be dependent on one another. Knowing that it's snowing changes the probability that you're going to be delayed. The other way that we can take a look at this is we can say, hey, what's the probability of a delay given that it's snowing? We saw that that is 12 out of 20, or 0.6. We can also take a look at, well, what's the probability of a delay given that it's not snowing? And that would be, well, hey, in 8 of the 330 days when, oops, sorry about that. How many days were we delayed when it wasn't snowing? So what's our total? Our total number of days where it wasn't snowing was 345. Of those 345 days, so I'm just taking a look at these 345 days when it wasn't snowing. How many of them were we delayed? We were delayed 23 of them. And so if we take a quick look at our calculator, we can see that that's happening 0.0667, or 6.67% of the time. So all of a sudden, again, we see a bit of a change, we see a bit of a problem, or not a problem, just a relationship. So what does this mean? It means that in a given day, you've got a 90% chance of it snowing. Sorry, let me pause. You got a 9.6 chance of being delayed. But all of a sudden, if you know that it's snowing, you got an increased chance. Those two things depend on one another. Being delayed is affected by it snowing. So what we can say is two ways to check for independence. Okay, we just showed that these events were dependent. So let's see what would happen if they were independent. Okay. A and B are independent if the probability of A is equal to the probability of A given B. If knowing that it was snowing outside didn't change the probability that your bus was going to be late, those two events would be independent. The other way that you can check it is the probability of A given B should equal the probability of A given not B. So if, for example, the probability of your bus being late when it was snowing was the same as the probability of your bus being late when it wasn't snowing, then again, those two things wouldn't have any impact on one another and the events would be independent. Hope this helps. Please let me know if there's anything else I can do for you, and I will see you next time we see each other in class.